So hello everyone and welcome to this next lecture. In the previous lecture, I had downloaded and installed controlSUITE, right? And this is where we had left off. Since there was no dialog message that told us that we need to restart our system, I am not restarting the system. And there should not be a reason to restart the system because controlSUITE does not install any drivers as Code Composer Studio did. So therefore, we do not need to do a system reset. If, however, you did get a dialog saying that you must reboot your system, then please do so. Now, let me go and show you where the files are. Now, I had installed controlSUITE inside the CCS directory in my F drive. And the reason for that, as I already said, is because my C drive is not very large and therefore I will very soon run out of space if I install both Code Composer Studio and controlSUITE in my C drive. So as you can see, there is a controlSUITE directory in F drive. So I'll click on it. And these are all the files which are installed. Now there should also be a desktop shortcut. Well, there isn't, but there sometimes is. And I'll just go through what are the files which are there. Okay. Of course, there is also an uninstaller. I think this should be this should be the uninstaller. Or you can just uninstall using your control panel in your Windows. Right? I won't show you that. If you want to uninstall, by all means do so. But I'm going to use it, so there's no point in showing you how to uninstall it. Now, what is most important? And that's what I'll show you. Now, there are several directories which are there. The most important are these two directories, development kits and device support. Alright. Can I increase the size of this? Let me see. Let me maybe use large icons. Yeah, because at least then it's easily visible. So these are the two directories which are most important. That is development kits and device support. So I'll just browse through this and tell you what this is. So if you look at development kits, these are all the development kits which can be available, which are available and are sold by Texas Instruments. Alright. Now, some of them are specifically used for various applications. Like for example, there is a buck boost bidirectional controller, which apparently is one of the development kits specifically for buck boost converters, which is available. Alright, so you can, if you have any of these, by all means check it out. Now there is also Piccolo control stick. Right, this Piccolo control stick is pretty similar to what we also have, because what we have is the F28069. But in any case, I will not be using it directly because I'll be using another set of files. But most importantly, I would say go through this, and if you have available to you any of these any of these development kits, then by all means give it a try and see what these projects look like. Right? Now, I will go back and I will show you the other directory, which is device support. Now, device support includes device for every microcontroller chip which is available. Now this is the chip which you are talking about, right? So for example, if you see there is an F2802X, what this means is this X stands for any number. So it could be F28021, 28022, 28022 and so on and so forth, all the way up to 28029. I don't know how many are available. Now in our case, we are using the TMS320 F28069 microcontroller, and that comes in this one. So let me just again go back and show you large icons. It is this one that I'm looking at, right? Because F2806X means it is the 2806 family. X can be any number. In our case, it is 9. X is 9. So let's go and have a look. And here again, this is the reason why I'm showing you these files, because there are lots and lots of files. And it can get a bit confusing because what are you going to use? So there is a V100 all the way up to version 151. Alright, go ahead and look through any of them you want, but I would say pick the latest version, that is version 151. Okay, now if you want, you can open this and it will tell you what it is. So for example, I can just open this with Google Chrome. This is an HTML file which tells you what is there in this particular folder. Right. So for example, if you just go through this, it just tells you what this is. There is a license version, export control, all this, right? this is the usual stuff. I'll go down to this. So these are all the directories, and it tells you where it is, and it also tells you what these are. So for example, you see some of them are source files, some of them are binary files. Right? Now, if you want, go through this, but there's not much detail here, and one of the reasons why I'm making this course is because I would like to give you those details. So let me have a look at these directories. The doc file is of course documents, right? So you can read through any of these you want, just to tell you what these are. These are documentation files. The common files, right? Common files include lib source. I'll talk about this in detail, but we are going to use this directory to a great extent, right? So let me continue. Then there is F2806X examples CCS version 5, right? Now there is a couple of things that you would want to know. Let me actually expand this because it may not be that easy. Okay, now that it should be easier to read. So we already went through F2806 common. This is a very important directory, but I'm not going to talk about this right now because this directory is a very detailed directory and I'll have to actually go through each and every one of them in detail. So I'll just skip it for now. The next one is examples CCS version 5. Now again, examples means these are example projects, a very useful directory. CCS version 5 means it is the Code Composer Studio version 5. Now that is significant. Why? Because we are using version 12. This project file is for version 5. So this shows you how old these projects are. So that is important because we'll have to make some changes to those projects even when we use them. They won't work right out of the box. Now, the next one are also examples files, but it has a CLA, which means it stands for the Control Law Accelerator. Now, the DSP 280, or rather the DSP version which we are using, which is the 28069, has a Control Law Accelerator which allows you to perform certain mathematical operations much faster. Alright, and you can look through this. So let me just show you the example file. You see, these are all the examples which are available, and I'll show you some of them. We will use them. We will use them, and we will use these as a base for building our own examples as well. Now, in Control Law Accelerator, you will see these are mainly mathematical functions. These are cosines, inverse cosines, and so on and so forth. These are mathematical functions which, using the Control Law Accelerator, one can do much faster than normal mathematical operations, and therefore if you have such advanced mathematical operations, you can consider using the Control Law Accelerator. In this course, I will not be going deep into advanced control, so therefore I will not be using this directory much. I will not be using this directory at all, actually speaking, right? I will be using examples and I will be using the common directory. The next directory is headers. This is also an extremely important directory because it contains a lot of header files for our microcontroller, right? Now, let me go back here. Mware is a random directory. I do not really know what this is, but we don't use it. The most important for us are 2806X common, example CCS version 5, and headers. So these three directories rather, not files, are what we will use again and again in this course. So let me just go through and tell you what these are. First, let me start with headers. Now, one of the biggest advantage of using controlSUITE is it makes programming much easier. Now, I'm not sure if you have actually ever programmed any microcontroller using assembly language, but it is always possible to do so, right? Because in order to control, or rather configure, any microcontroller, all that one needs to do is to know which registers need to be configured in which manner. And these registers need a hexadecimal value, or for that matter even a binary value, right? But programs written in such a manner using hexadecimal and binary are very difficult to debug and even understand. Alright, so if you are writing your programs, you might be able to understand it, but anybody else reading it, or for that matter, even if you revisit those programs after a few months, you will have a very tough time understanding them. And that's where these header files come in. Let me just make it large. So the header files have few of them. So for example, there is, first and foremost, in CMD, there is a BIOS and a non-BIOS. I'll show you this later, but these are the operating conditions of your microcontroller. They can work in BIOS mode or they can work in non-BIOS mode. Again, more on this later. The include file, include directory rather, has header files for each and every peripheral available on the microcontroller. So if you take a look, let me just go to large icons, and you can see there is a header file for the ADC. This is the analog to digital converter. There is a header file for the PWM. So this is for all the PWM ports which are there in the microcontroller. There is a header file for the GPIO, which is a general purpose input-output port in the microcontroller. There are for almost everything, right? These are the main ones which we'll be using, but just to give you an example, that there is a header file which is there for each and every peripheral on this device. So if you're using any peripheral on this device, go through the header file corresponding to that. Now I'm going to just browse through the GPIO.h file. So you can use many of them. I'll just use Notepad because I just want to show you what it is. So the header, the top of it is just a few comments. You see what it is? It is the 2806X device GPIO register definitions. Now, in this course, I will be showing you the registers for each and every peripheral in the microcontroller and how those registers can be configured so that we can control our peripherals in a manner which we want to. So the question then is, what are these? As I will show you, these are definitions for all these registers. So these definitions here allow you to be able to control each and every bit of your peripheral registers such that now you do not need to write only hexadecimal values, but you can write human understandable code. And this is what we'll show you. But the main thing what I wanted to show you is that there are control registers for each and every one. So for example, this structure, it tells you these are all the control registers that control the two GPIO ports which are there in this microcontroller. The microcontroller 28069 has two GPIO ports A and B. And these are all the control registers which are available for those two, right? So, and of course there are also the data registers. So now the question then arises, how are we going to use it? This of course will come when we start programming. But what is important in this is I wanted to show you how and why these are important. These are important because now we have something for each and every one, and we can do the same for this as well, for the ADC. So I'll just remove it, open it, and you see there are all the same control registers. There are control registers for, or rather this has every control register which is used for configuring the ADC ports, right? So again, we will go through this in much greater detail as we start examining each and every peripheral. Now that I've gone through headers, let me go through the source file. The source file here has one global variables defs file. Now I'll show you this in greater detail when we start programming, but this global variables files is a general definition file which defines all these registers. So for example, what that means is that we use a lot of registers for configuring our microcontroller as well as all the peripherals. All these registers are defined as variables. That's why it's called a global variable definition file. This defines all the global variables that you can use for configuring your microcontroller so that you can then program it with all the other definition files that I just showed you, right? So this is like a global variable. This is like a global definition file, and those specific header files which I just showed you before, those are specific to a particular peripheral, right? So let me continue. So this is headers. Now we've already seen CMD. CMD, as I said, I'll show you later, because the concept of BIOS and non-BIOS will come when we actually start running code. Include I've shown you, source I've shown you, right? Now let me go over and let me now show you the common directory, right? Again, let me expand this, large icons. The common directory has several of them. This also has a similar structure. So you see there are only two directories which are additional, which is GEL and lib. The CMD, include and source were also there in the headers directory, right? So let me go and have a look again. In this CMD, you will see many of these files. These are RAM mapping files. So every microcontroller has a RAM which you can use depending on your application in a way you want. You can write your own mapping files, but for simplicity, there are many already ready-made RAM link files which you can find and use at your convenience, right? And in many of the projects which are already available, these RAM link files are already being used, right? So this is just to show you. Again, I won't go into the detail. I don't want to open any of them because these are fairly complicated, and to describe them will need some theory. The next one, GEL. The GEL files, right? So let's open the one corresponding to our microcontroller. Let me open with Notepad. The GEL file is typically not for us, right? This is something which you do not want to play around with, right? The only reason why I wanted to show you is that this is something which is specific internal to this microcontroller. Microcontroller will use it. You do not have to bother. The include. Similar to the include files in the header directory, you will see there are definitions for each and every peripheral here as well. Alright, and you will see there are many definitions here. Some are for EPWM. There is nothing for GPIO, but there are many others. Now, these definition files are again a little complicated, and it is best to describe them as we start building our projects. But these files are extremely important, and you will always come through them in any project, right? I will describe them later, but go ahead and browse through them if you need to. Again, little complicated, so I would say wait until we actually start programming. The lib. The lib, of course, these are library files which are used. You do not need to know them. You do not need to use them. So I will skip right now. There's nothing here to see. The source files. These are very important. Let me expand it so that we know. And once again, you will see a number of files corresponding to each and every peripheral port. So for example, there is an ADC, there is an EPWM, there is a GPIO, and there are many more, depending on whether you use it or not. So let me just open this GPIO, because GPIO is the easiest to really start with. And starts here. So you can see here again, these are helper functions. So for example, you see you can go ahead, general purpose IO, initialization and support functions. Now again, the contents of these files are not necessary to use. You can write your own programs, but there are several actions that we need to perform whenever we use any peripheral, and therefore this control suite contains all these functions so that we do not have to write them ourselves. Rather, we can just call these ready-made functions. So for example, init GPIO. This function initializes a GPIO to a known state. Now, this is a helper function. You don't have to use it. But by using this function, you do not have to write your own code. So, the advantage of these files is it makes your life much easier by giving you ready-made functions that you can just execute instead of having to write all this code on your own. right? You can by all means write this code on your own. You don't have to use this, but it just makes your life easier. So with this, I'll close this. So with this, I think I've browsed through most of the files here. As I said, there are a lot of files, and the only way to actually make any sense out of all this is by actually programming and going through it bit by bit, right? Whenever we program any peripheral, we are going to go deep into which files are used, what are the contents of those files, and how do we make sense out of those files. That's what we're going to do in this course. So what's important is that after installing controlSUITE, you should have had this directory, and you should get all these directories also, subdirectories. Most importantly, you must get development kits and you must have device support. If you do not have device support and you do not have these directories, right, especially 2806X, which is what we're going to use, then in that case, please do post in the Q&A forum and I will try to help you out. If you have these files, you are ready to go and you can continue with the rest of this course. So in the next video, I'm going to start by running a sample project in this example file. Alright, so for this, of course, get your kit ready, get your USB cable ready, and connect up your kit to your computer so that you can start running code. So thank you so much for watching and see you soon. Goodbye for now.